Welcome back to the channel Wi-Fi Tech Lab. Today we are breaking down the layer 2 switches, layer 3 switches, and the difference between managed switch and unmanaged switch. Okay, so I'm gonna be using the Cisco Packet Tracer as the simulation tool, which is gonna be the tool that I'm using all through the demonstration and the configuration as we design the network from small office, home office, 2-tier network, 3-tier. Okay, we're also gonna be touching up on campus network, hospital networks, and so on. Right, maybe before we jump into the more complex designs or configuration, let's start with the basic one: small office, home office, which we gonna be only focusing on an access layer. Okay, so this is my Cisco Packet Tracer again. So what I'll do, I will just go to file and then I will just say new. I won't save this because it's already saved on my PC. So now this is the new field where I'm just gonna be freshly designing the access layer. Okay, so these are all my tools that I'm gonna be using. As you can see, these are all the cables that we have in this tool, Cisco Packet Tracer. Let me just start in here. So if you see here this option, it says automatically choose connection type. It helps us to it just pick the cable automatically for you. You don't need to know which cable is compatible with that particular device. Okay, and then this one is a console cable. It's also called rollover cables, basically used by network engineer or whoever is configuring the device physically. So you must have this cable in order for you to gain access to the device. Okay, and then this is a straight through cable. Of course, this is the cable that is used between the end host devices and switches. Okay, so you run this cable from the device, for example from the PC, or also from the laptop. It could be a phone, it could be a printer, all of those end host devices, and then you run it straight to the switch. Okay, and then this is a crossover cable, normally used between the same device of the same type, devices of the same type. For example, if you want to connect the switch to another switch, you can use this cable. It's called a crossover cable, and of course this is the fastest cable that we have. It's called the fiber or optic cable. Okay, and then you will also, as we move along, we will also I'll talk about different kinds of cables, also touch upon fiber or optic cables. So we have different classes, or we can say we have different modes of fiber cables. We have single mode, which is used for the longer distance, and then we also have multi-mode fiber, which is used for shorter distance compared to single mode fiber. And then we also have extended long range and short range, and also all those classes of fiber. Okay, okay, depending on the distance. Okay, so if you check on here, this is the coaxial cable, and this is a this is a phone cable, this is a coaxial cable, this is serial DCE, this is serial DTE, and this is a octal, this is an IoT customizable cable, and this is just a normal USB cable. Alright, now let's move to our left hand side. You will see that we have the network devices. In this case, we have layer 2 devices. If you look closer, these represent in Cisco Packet Tracer, these represent our routers that we have. And then if you move to the right hand side, this is our switches. These are our switches, and then we have layer 2 switches here, and then we have layer 3 switches, and then we have a bridge as well. Now we also have our wireless devices here. We have Meraki, we have APs, and then we have wireless LAN controller. Yeah, okay, and then we have a cell tower. Okay, and then we also have our ASA, our security appliances here, the firewalls. Okay, Now let's try to design just a simple local area network, which is gonna be including, or I may say it will just have a minimum of 5 pieces, okay, as a demonstration. So we having 5 computers on this local area network. I'll just create a beta so that everyone will see. I don't want to fill color. Let me just make this, and then I would like to call it my local area 1. Okay, local area network 1. Right, I can fill the color on this one. Okay, and then I will also create a secondary one, which I will just call it my local area network 2. The reason why I'm creating 2 is because I will show the static way of assigning IP addresses on this left hand side, and also on the right hand side I will show the dynamic host configuration protocol, which we can use to release IP addresses automatically to the client computers on the right hand side. Okay, so I would call this local area network 2 LAN 2. Right, and then I will just give it a different highlight as well, so that we will be able to distinguish between the two. Right, okay, it's fine like that. Now I would like to place another same number of PCs. I would place 5 computers. Okay, so basically now we have 5 computers on our right hand side. Right, okay, so we're trying to communicate these devices. For instance, on a local area network, we're trying to communicate these devices. Of course, they won't be able to communicate at the moment. The reason why is because they need, in order for each device to make communication on the network, they need to use IP addresses. Right, they need to use the IP addresses. So how does the computer get the IP addresses? Right, so basically, before we come to that, we're gonna be needing a switch. This is a switch. This is also a switch. I'll just place it here. Let me just call this switch 1, and then I will call the other one on the other end as switch 2. Right, so now we have 2 switches. Right, if I were to connect these 2 switches together, remember I said I was gonna use this cable called the crossover cable to link 2 switches. Okay, I wouldn't use the standard or straight through cable. Right, so to use this cable, you must use it on the devices of the same time. All right, so let me just highlight this. Okay, let me select fill color, and then I'll start again afresh. So these are our computers on the right hand side, and then we have these computers on our left hand side. Okay, let me try to move it further up. Right, okay, now we have these devices on the left hand side and also on the right hand side. This is a local area network 1, and the other one is a local area network 2. Right, so this is the switch. This is a layer 2 switch. Okay, again, if you want to know the main objective or the main purpose of the switch or layer 2 switch, this is your basic building block in networking. It operates at the data link layer of OSI model. So layer 2 switches, they use MAC addresses to forward data between the devices on the same network, okay, segment, right? Think of them as a traffic director. They ensure that the data packet reaches the correct devices based on their MAC addresses. So this device here, the switches uses something called a MAC address table. All right. Okay. To cut it short, I can just say layer 2 switches are great for local network where you don't need to do the routing between the different network segments. They efficiently simple, and they make an ideal for small table and send the packet to the correct ports. Right. Now let's try to assign the IP addresses. So in this case, we're just gonna use class C IP address. This is my network ID that I'm willing to give to this particular local area network. In this case, I'll just give it a highlight. All right, I'll just give it a highlight. All right, and then on the other side too, I would like to give another different network ID. Maybe in this case, let me use class B IP address /16. all right, this is a class B IP address. Of course, we also gonna be touching more based on how to identify the class A, class B, class C, or a multicast range IP address, class D, and also how to do the subnetting, how to change binary to decimal, and how to change back from decimal to binary, and so on. All right, but for now, let's focus on this simple lab. So we're gonna be looking at how the packet is moving from PC0 to PC4 or any other devices on this local area network. Right, remember, on the local area network, we don't need to configure any routing. Everything within the network, they just can communicate as long as they have the IP addresses that is known by other devices on the same network. Right, okay, now what is left to do is we need to basically give static IP addresses addressing. I'll just call it static IP addressing, and then on the other side, I'll just call it DSCP addressing. Okay, so I'm trying to hit two birds with one stone. So basically, we have a static IP addressing on the left hand side, and then we have DHCP addressing on the right hand side. Right, so here we have a switch. Now we're willing to communicate or willing to send a frame or a packet from PC0 to PC4. all right, however, at the moment, these computers, they don't have any IP address assigned to them or assigned or attached to the network interface card that they have. Right, if you look closer at the physical device itself, you will see that the modules installed on it. As you can see, this is a network module, it's a network interface card, it have an auxiliary jack, and then it also have the USB ports, and I can switch it on, switch it off, and switch it on. Okay, this is a simulation tool again, remember. Okay, so let's switch it on. All right, the rest of the computers on the right hand side, they are also have been switched on, as you can see. Right, So what do we do now? Initially, the computers, they don't have any IP addresses configured to their network interface cards, so which means they cannot be able to communicate. Again, we are using IPv4 at the moment to demonstrate the communication between the devices. However, as we move along, we're also going to be touching more based on the IPv6 configuration. This is the link local IP address on this device. Okay, now we said we are going to be using this network ID on this LAN 1. So we need to know what are our usable IP addresses on this network range. Okay, so basically we all know that the usable IP addresses under this network ID, which is 192.168.1.0/24, we have 254 IP addresses. All right, so basically we're gonna be having a range from .1 up to 254. Right, but somebody may ask, how does this 254 come from? Where does it come from? Right, we have a specific formula that we normally use. It's called 2 to the power of n minus 2. This is the formula that we use to calculate the number of IP addresses, of usable IP addresses on that network. Right, I will also talk about this as we move along, and to demonstrate and show where is it coming from. All right, okay, but for now, as you see, this is gonna be our range that we can use, or this is the range that we can assign the devices with. This is the IP address range that we can assign the devices using. All right, so in this case, let's start by this one. Right, we can assign the IP address to this device with .1, .10, and then the subnet mask, as you can see, just auto populated itself, so it's 255.255.255.0, and then the default gateway can be 192.168. It could be also any IP address within that network range. So in this case, I'll just use 192.168.1, which is a common IP address that is used, and then I'll just give it just a random DNS server. If you have a DNS server or a physical or bare metal DNS server that you have in your network infrastructure, of course you can point it to that address. All right, in this case I'm using a Google DNS. This is a primary Google DNS. Of course you can also use 8.8.4.4 as a secondary Google DNS, or you can use Cloudflare 1.1.1. right, but in this case I'm just going to demonstrate using 8.8.8.8. right. All right, okay, so I'm already done configuring the network interface of this device here. I would like to configure the network interface of this device in this side, because I'm assigning the IP address statically. I will explain why I'm doing this for now, and then I will also explain why it's not a good idea to do this. All right, so 1.11, and then we gonna carry on do the same thing. All right, so let's do the same thing. This is gonna be 1.13, or this is gonna be 1.12, and then the default gateway is gonna be the same, and then we also gonna have shared DNS. So let's move along to PC3 and do the same thing again. So what we do now, we're gonna give you the IP address of .13. okay, this is our subnet mask that we have for /24, and then we're gonna give the default gateway same way as we've been giving all of the end host devices on local area network 1. right, let's give this one dot 14 dot 1 dot 1 8.8.8.8. all right, now we have assigned the static IP addresses. Now what does static mean? Static means something that does not change. All right, it just doesn't change. So the disadvantage of assigning the IP address statically on the device or the end host device. Imagine now if the company or the infrastructure have more than 500 computers in the network, or maybe more than 200 still. It can consume a lot of time when a network engineer or someone who was a tech to assign the IP address directly to each and every devices on the network. All right, and also it is a bad idea, because if the company decide that they willing to change the IP address or they want to make changes on the network, it will require a network engineer or someone who's tech wise to do all over again, do the same thing all over again, to update it from a previous IP address that were assigned on devices to the new IP addresses. All right, so which is why we're using a dynamic host configuration protocol which releases IP addresses based on time. All right, okay, so we use static IP addresses in devices such as servers that doesn't require their network interface card to have a changing IP address. All right, okay, so now what is left is to connect these devices to the switch. All right, I'm just gonna hover over this switch, so you will see that this switch have okay, maybe let me just do this. If you take this cable and plug it to the available port on the PC or network interface card of that personal computer, you can just select the fast Ethernet 0 as if you're plugging in real life. Take it as if you are plugging a network cable on the PC, and then you're plugging it straight to the switch. On the switch itself, it have 24 ports. In this case, the one that we're using is a managed switch, and it have 24 ports and some extra 2 ports, gigabit Ethernet ports, and then we have a console cable, and then we just need to select any of this cable, any of these ports where we would like to plug our cable, the standard or straight through cable. Right, so in this case we're just gonna select fastener 01. Okay, now the cable has been connected successfully. Right, now we're willing to do the same thing for the rest of the PCs, but I would like to speed this up. I will just connect to fastener 02, and then I'll select this automatic option that's gonna automatically plug in the cable for me. All right, on the next available port on the switch. All right, now I'll do the same thing on the right hand side. Okay, okay, now we have successfully plugged in our cable, or we have connected our cable directly to the switch. All right, from the end host devices or from the PCs to the switch directly. All right, now if we come to this switch, remember we said there is a difference between the managed switch and an unmanaged switch. Right, so what is the difference between the two? You will find that there are types of switches that you can just buy wherever you bought it from, or wherever you bought it from. You can just buy it and just go plug it in the network without any effort of you being have to configure anything or any protocol or on the device. You just plug it in and play. All right, in this case that switch is limited. You cannot perform some configuration on them. You cannot configure a spanning tree. You cannot configure VLANs. You cannot configure many things I can count. You cannot configure the host name. You cannot configure the banner message. You cannot configure the device security and so on. Alright, all you do is just plug in the device and then it works. However, on the managed switch, it's quite the opposite. It has some extra features that comes with the device itself. So as we move along, we're gonna see all of those features. Alright, if you go back to the video that we lastly posted, it talks more about the device configuration, security device. So I mean device security. Okay, but as we move along again, as I've mentioned, we will be showing all of those features that the managed switch comes with. Alright, so initially when you unpacking a switch, you will find that the switch have no configurations on it depending where you bought it. In this case, suppose that we want to verify that the switch itself is not being used before and it doesn't have any configuration saved on an NVRAM. So what do? Alright, so you plug in the switch, switch it on, and then you plug in your console cable. If this is what you be doing on a real life scenario, you plug in your console cable and then you use software such as PARI to connect to the device or to SSH to the device, and then it's gonna bring you here. The switch or the layer 2 switch that we're using at the moment, it is not enabled. So in Cisco we have a command for enabling the switch. It's called enable. So once you click on the switch, it's gonna bring you to privilege config mode. On the privilege config mode, that's where you can be able to type in the commands such as show running configuration, and then the switch will now show you all of the configuration that have been saved or that are on the switch itself. So as you can see, the current configuration takes about 10. This is a 1 gigabyte, so 1 gig megabytes, and then so it's 1080 bytes, which is 1 gig. So the version is 15, and then the host name is just the switch. As you can see, the host name is not being changed so far. This is our host name. It's not being changed. Its default is just the switch, and then the spanning tree mode is per VLAN spanning tree, and then the interface fastnet01 is not configured to be on a VLAN and so on. So if we move down, we can also see that SVI is not configured. This is what we use to assign the interface or the IP address to VLAN. Okay, the line console also, it's not configured. The line VTY, which is used for transporting the SSH and telnet, is also not configured. And then if you move down, now remember we are on a privilege config mode. To do our configurations, we need to navigate to something called a global config mode by typing in the command called config terminal. Alright, config terminal. Now that we are on a global config mode, this is where we can actually do all of the configurations that we're willing to configure on this device. Remember, we said this is a managed switch, so the managed switch is always ready to receive some configurations. Alright, okay, so what are we willing to show on this switch? I'm willing to show you the real time or the simulation when the packet leaves from PC0 and goes to PC4. But before that, this traffic director, which we call layer 2 switch, it's gonna be performing some job before it's forward the traffic to PC4. Okay, so it's gonna take the frame, or it's gonna take the packet look for the destination MAC address and see if it's available on a MAC address table. And then if it's not available on the MAC address table, it's going to flood the packet to each and every one on that segment. And then whoever having the same MAC address that the PC0 is sending a message towards, it's gonna reply and say, here I am, I have the same MAC address, and then the switch will save the MAC address to the MAC address table, so the next time when the same computer send the packet towards that destination, it will know exactly the path to go to that destination, and by saving the port of that path and also the MAC address of that device. All right, so we're gonna be observing all of that. This is also called ARP, okay, address resolution protocol. All right, so before we come to that, let's run a command to see do show IP address brief. Okay, do show IP interface brief. Do show IP interface brief. All right, so if you type in the command do show IP interface brief, you will see that from fast Ethernet 01 the interface is up because we have a cable directly connected to it until fast Ethernet 05, right? Because we have 1, 2, 3, 4, 5. These are our devices that are currently connected to the to this switch. Now if you look down from fast Ethernet 06 up to 24, you will notice that the status is just down. It is down because there's nothing that is currently plugged on that ports on the switch. Okay, now if we move further down, you will also see that the VLAN 1 is unassigned, right? Administratively down. All right, now what are you willing to also know? You wanna print out do show VLAN. By default, each and every interface is on the managed switch, they belong to VLAN 1. So if you come here, you will see this is a VLAN and this is a VLAN ID, and then this is VLAN name. This is called a default VLAN. If you look, all of these interfaces that the switch have 1 up to 24, including the gigabit Ethernet 01 and 02, they all belong to this VLAN, which is called the VLAN 1. All right, okay, enough about that. Now let's go back to something called a MAC address table of this switch. If you come here and also say do show MAC address table, or do show MAC address, sorry, you will see that it doesn't print anything, so it doesn't show us anything. Currently there is no land MAC address on the switch. All right, the switch doesn't know anything at the moment because there is no one who tried to send anything from source to the destination. Right, this is what we're going to be looking at now as we sending a packet from here towards PC4. Remember now that although the switch operates in a layer 2 or data link layer of OSI model, it's also when the packet is sent from the device, it carries the MAC address and also the IP address of where it is going. Okay, so now let's try to ping. Let's select this as a simulation so that everyone will see. Let's try to ping PC4 from PC0. If I place this here, you will see that this is ready to leave. So what we're willing to see now, we're willing to see that as the packet leaves from here, it will move from this switch, but then the switch, because now it doesn't currently know anyone or who's connected to it, So it will be asking everyone who have the destination MAC address that the packet from PC0 is sent towards, right? So let's play it now. Let's see. PC0 to the switch doesn't know where is it supposed to send the packet, so it's flooded to everyone except from the interface that it's received the packet from. And then whoever had the packet just replying now, whoever have the MAC address just reply now and says, okay, I am. Now the switch, what it does is, because now it got a reply from that PC4, it will then save the MAC address of PC4 to its MAC address table, right? Now you will see that the next time we go to the switch and type in the command called do show MAC address table, you will see that now it must have saved the route or the port which can be used to send the packet towards that MAC address. All right, as you can see, the status is successfully. Now let's pause this and come to the switch. I'll write down the same command. I'll type down the same command, do show MAC address. Okay, so it landed two MAC addresses. All right, if you look close, it land MAC address 00C 8595 3ED5. right, it's dynamically land this MAC address which is located on the same segment, which is a VLAN ID 1, and also it landed via a specific port which is FA05. Now let's confirm if PC4 have the same MAC address as the one that the switch have just landed. So if you go to your PC normally, you can just type in this command ipconfig all. Okay, you will confirm, you will see that this is the same exact media or the MAC address, media access control or MAC address that the switch just saved. So it's 0. Let me just put this one again so everyone will see. So it's 000C 8595 3ED5. All right, let me just come back to this one. It's 00C 8595 3ED5. This is the same one that has been landed, all right, by the switch, right? If you pay attention, it didn't land PC1, PC2, PC3, so it still doesn't know about them until we send the traffic from a particular end host device toward that particular destination. Right, now let's send another one which is gonna be coming from here to PC3. Right, so let's do the same thing. Let's run it. It will send to the switch, because now the switch doesn't know very well about PC3. It will flood the packet to everyone except from the interface that it received from. And then PC3 will only reply because it have that specific MAC address that the switch was carrying and it was receiving it from PC0. It's know that the destination MAC address was for PC3, so PC3 replies and say, okay, I have that MAC address. Now the ICMP take place now. Okay, right, now as you can see, this is successfully right. So if I go back to our MAC address table, do show MAC address table, you will see that the switch now has landed another MAC address on the same segment, on the same VLAN ID, right? So it's dynamically land this media access control address via fast 04. If you look close, this is the interface that it land the MAC address for this device from. All right, Okay, now next time we send the same packet, you will see it won't flood it because now it knows exactly where the PC3 is located. Now let's do the same thing. Let me just delete this so everyone will see. So if I send now the packet from PC0 to PC3, you will see that it won't flood it this time because it's not exactly where PC3 is located. So we're sending ICMP echo request to PC3, and then PC3 replies with an ICMP echo reply. Alright, PC3 replied, and the switch didn't have to flood the packet to everyone except from the port that it received from. Okay, now it's successfully. Right, so the same thing, if I can try to send from PC0 to PC4, it won't need to flood the packet. The switch won't need to flood the packet. It will just send it straight to PC4. Okay, now it's send it to PC4 because it's not exactly where to find PC4 on the network. Alright, successfully again. Alright, if you look close here, the status is just successfully. This is how the switch operates. If everyone didn't know about the switch, there is something called collision domain, and then there is also something called broadcasting domain. Each port or each interface on the switch represents its collision domain. So each interface is a collision domain only on what? Only on the switch. Alright, let me just delete this one. Let me do one more example with PC0 to PC1. Alright, PC1 is not known, so we're willing to see that this interface now will be lent, which is fast Ethernet 0/2. Alright, so as I play it now, you will see, because the switch doesn't know again where PC1 is located, so it will ask everyone who have this again, who have this MAC address. Only PC1 will not have that X, so PC1 will reply and say, okay, I have that media access control address that you're asking for. Okay, and then PC0 says, okay, alright, now we can communicate. And then the switch now know exactly where to send the packet towards PC1. Alright, you will see that now the status says successfully. Now let's go back to the switch one more time to find out if this interface has been learned. So now if you look close, fast Ethernet 02 has been learned, which is this one. The switch just learned the new MAC address via fast Ethernet 02. It's dynamically learned. The list goes on and on and on and on and on and on. So whenever you have a device within that network segment trying to communicate with another device on the same network segment, the switch, if it doesn't know the destination of that packet, it will flood the packet to each and every devices on the same network segment, and then whoever have the same MAC address will reply and say, okay, I have that MAC address, and then the switch will just save the MAC address on its MAC address table. Okay, now let's move across to DHCP. Alright, on the DHCP we will be introducing some new end-host device in here, which is called a server. Right, so if we put in a server in here, in this case we would like to call it a DHCP, or a bare metal dedicated DHCP server. Right, so let me just do this. Let me just pause that one. Now DHCP server is also an n-host device, right? I will just directly connect this DHCP server to a fastnet 01. Remember, the devices that are directly connected, they have the distance of 0, right? They have the distance of 0. We're gonna talk more about the distances as we move along. All right. So what do we need to know about the DHCP server? Or maybe I can also introduce something called the DNS server on this side to cut it short. All right. So if I use the same automatic cable selector, okay, it will pick the standard or straight through cable. All right. So now we have a DHCP server, and then we have a DNS server on the left hand side. And also please note that we have a 172.16.6.0, which is /16, a class B IP address. All right, so we're willing to lease all of these client computers with the IP address that is pulled from a DHCP pool on this server. Right, this server, we're gonna be leasing the IP addresses to these client computers based on the lease type. All right, and then we will have a DNS server here which resolve the names, the IP addresses into names. All right, so let's focus on the DHCP server for now, because we're willing to see these devices, or the network interface cards of these devices getting the IP addresses from the server. All right, from the server. We're not gonna be physically, or we're not gonna be logically assigning these IP addresses on the network interface card statically, just like we did on these ones. We're just gonna be using a DHCP server this time. All right, so now let's do it. So if you come here on a DHCP server, remember what I said. I said the only devices that we can comfortably use the static IP addresses on are the servers. Most of the time we use static IP addresses on the servers, on the routers, on wireless LAN controllers, and or you can count in many devices. All right, so in this case, because this is a server, we can use an IP address. Right, in this case we're using a class B IP address, using /16. Of course, if you don't know how to differentiate between class A, class B, class C, I will also, on the following videos, I will also be demonstrating on how to identify and how to calculate all of those. All right, so we have 172, we have 16, and then we have 6. All right, we can use any IP address within a network range of class B IP address. Right, so in this case I will just give it an IP address of .100. all right, 172.16.6.100, and then if I press, as you can see, if I press tab on my keyboard, it just auto populates. As you can see now, the subnet mask has changed. This is a class B IP, or sorry, subnet mask. Right, so remember, each and every IP address is made up of 32 bits. The first 16 bits, they represent the host portion, the network portion, and then the last 16 bits, they represent the host portion. Alright, so if you take the number of these bits on the host portion, they will determine the number of usable IP addresses on the network. Alright, by using the same formula that I used in here. So you'll be saying 2 to the power of 16 minus 2, it will give you the same number exactly of the number of usable IP addresses on slash 16 network. Alright, now on the default gateway, we can also use 172.16.6.1. Okay, and then the DNS server, we will point it to a DNS server that we will be configuring here. For in this case, I'll just use 172.16.6. I'll give it .200. Alright, this is just gonna be our network interface card configurations. Alright, so we need to enable the DHCP service on the server in order for us to be able to use the DHCP server. So by clicking on a DHCP server, this is a DHCP server for IPv4 addresses, this is a DHCP server for IPv6 IP addresses. So for now we are talking about IPv4. Of course, I have to switch on the service, and then also what I would like to do is I'll give it a name, but in this case I'll just leave it as a server pool, and then all I need to know is the default gateway of this network. In this case, I know the default gateway is 172.116, sorry, it's 16 and .6.1, and the DNS server is the server I said it's just gonna be 200. And then we also need to specify the pool. Our pool will start from .6 .6.10. Alright, and I'll leave the subnet mask as it is, as a default subnet mask, and then I'll just save this. Alright, now everything is done on the server itself. Alright, we have created the pool. The pool have inclusive of default gateway, the DNS server, the range or the starting IP address, the subnet mask, and then the maximum user. This is not set up. This is a tribal file transfer protocol. It's not configured as yet, so we can leave that for now because our main focus is on the DHCP server. Alright, now if I come back to a DNS, you will see that I need to give it an IP address also, which is 16.200, and then our default gateway 6.1, and then I'll point it to itself. As you pay attention on the network interface card here, I'll point DNS to itself. Alright, there is something more I need to do in here, which is enabling the service DNS. Alright, so I'm gonna switch it on, and then I'll just say Wi-Fi Tech lab, and then I'll just type in the address, which is 172.16.6.200, and then I'll just edit. This is added as an A record. Of course, if you know about DNS, you will know that there are different types of record. There's TX record, and then there's A record. There's a lot. Okay, now everything is ready. So if I come here on PC5 and go to its network interface card or adapter settings, if I select DHCP service, it will automatically have to obtain the IP address from the DHCP server. It won't now because I have to play it. Maybe I should do this for now. I must move it to a real time so you will see it. As you can see, the DHCP request is successfully. Now the client have been listed with an IP address 172.16.6. Remember the range we specify on the pool. We said we want the DHCP to start leasing the IP address from this range, from 172.16.6.10, and this is the subnet mask that all of the devices have for this network ID 172.16.6.0/16. And then we have this default gateway 172.16.6.1, and then also we have DNS server. Alright, if I can move along to the next computer, we can also enable the same DHCP service, and as you can see, all of these devices now they are being leased within IP addresses. This got to 6.12, and then let's see, this one will have to get 6.13 if I'm not mistaken. This got 6.13, and then let's check this one. This one is listed with 172.16.6.14. Alright, this is how the DHCP server is configured, and this is how also the static IP address is configured. So we have covered a number of things in here. We have covered the layer 2 switch, ARP lookup, and then we also have covered how to configure and how to configure a DHCP and a DNS server on a class B network address. Alright, I hope this video was so informative to you. On the next video we will be continuing with the same lab, and then we will try to introduce some other configurations we can also look for